Hi, so we're Braille-iant, and this is our product. So the inspiration for this comes from the most recent Valentine's Day. We felt that one of the cutest and most heartwarming things you can get from a significant other is a handwritten note. Unfortunately, we felt like for those who might have any vision impairments or blindness, they wouldn't be able to experience this as well as be able to keep a note for a very long time. So what we came up with was Braille-iant, and Braille-iant is a full-fledged website connected to a Braille printer. Now, as you can see on this website, what you're able to do is actually create your own letter that is completely customizable, or you can follow one of the templates that we have. So as we click, you will see, and we'll actually go with customize in this case, because one cool thing we implemented is, if you don't actually like any of our templates, you can submit a link to your own image, and we'll use computer vision to process that and analyze it and turn it into a description that a blind person can understand.
So we'll click on customize and we'll fill out this form. So I'll be sending it to Dylan. And then I'll attach an image. And for the message, I'm gonna say howdy.
So once you've filled out the form, you can go ahead and press preview message to make sure everything is exactly how you want it. You'll get to see both the picture that you chose as well as a short description that we generated using the computer vision.
So for the computer vision, we used Google Cloud in order to develop a description for the image. And now we can print the message.
So in order to print it, we need to first provide power to the circuit, and then it'll start homing itself. And once it homes, once it homes itself, it's now ready to start printing.
So we'll go ahead and press print message and watch as it comes to life.
So the mechanical design of the printer, it's similar to a 3D printer, but it lacks the Z-axis. As you can see, the X and Y axis are based on linear rails that are controlled with stepper motors and a belt-driven system. This allows us to access basically every point on the paper with sub-millimeter precision, which is necessary in order to conform to the standard Braille code of America. So every blue part you see here was designed in the last 24 hours and 3D printed specifically for this purpose. So because of that, everything fits this use case really well. The hardware and software integrate really well. Everything works really well.
All right. So in order to implement the electronics, we have one stepper motor for the x-axis, one stepper motor for the y-axis, and one controlling the pen mechanism that makes indents in the paper to make the Braille. So each of these stepper motors is connected to an A4988 stepper motor driver, which takes in a higher voltage, anywhere from 5 to 35 volts for the stepper motor voltage. So here we're using 15, and it takes in 5 volts for the logic. So for the logic of how this program works, it essentially takes in the text that's sent from the website and then takes it into the Arduino. The Arduino then takes that text and then converts it into Braille. And then there's also another algorithm that takes the Braille, mirrors it, and then processes it in order to make sure that it has enough precision while moving the stepper motors in order to actually accurately represent Braille. And this was the root of one of the greatest problems and one of the greatest strengths of this printer. Well, it's because in order to conform to Braille code and have blind people be able to read this easily, there needs to be a very specific set of dimensions between each dot, between each character, and between each line of Braille, so that there's as little of a learning curve as possible as compared to existing Braille. So in order to do that, I went ahead and quarter-stepped the motors and calculated using the diameter of the belt system how many millimeters per step and how many steps per millimeter I would need in order to move the stepper motors around, so I could move them with as much precision as I would need. In order to convert the Braille to the actual code for the servo, for the stepper motors, I made a matrix, filled it in with the Braille, whether it was indented or not, and it would mirror it using an algorithm, and then write it from right to left using a predetermined set of differential change based algorithms.
Yeah, so as you can see, now we have our printed Braille. And you can verify it with our mapping.
And so together, we can make something Braille-iant. Thank you.
Thank you.